Hello, we are asked to solve a quadratic equation, and we can see on the screen we have multiple methods by which to potentially solve the quadratic equation. So the first method that we're asked to solve is by factoring, and in order to do that we're using the theorem that tells us if a times b equals 0, then either a equals 0 or b equals 0. So we have the beginnings in that we have this set equal to 0, and so we would want to see, can we factor? So we split this into our factors. 3x squared. Well, that would have to split to be 3x and x because 3 is prime. And then we're looking for factors of 1, and so we can do 1 and 1. And then we check. So we check our outside terms, so 3x times 1 is 3x. And we check our inside terms, and 1 times x is 1x. And they add up to 4x, which is definitely not negative 5. So going back, we can try again. So we could take those out, and we can make negative 1 times negative 1, because we know that two negatives make a positive. So if I check my outer terms, I get negative 3x. Check my inner terms, I get negative 1x. Together they make negative 4x, which again is not negative 5x. So with that amount of work, I'm going to say it's not factorable. And when I make that conclusion, that is more of a for me than in general. So if you try a time or two and you're not figuring out the factors, you can stop and just be like, I can't do this, because there are other options. So we don't want to spend tons of time trying to figure this out if it's not easily done. Our next option is graphing. So we're going to go to our graphing calculator. We're going to type this formula into our y equals. So here I am at my graphing calculator. I'm in my y equals screen, and I have typed the formula from our previous slide that we're trying to solve. We don't know a lot about this. I do know that it opens upward because a is positive, and it's fairly narrow because a is bigger than 1. But when I don't know a lot about it, my zoom options are a great place to go. So I'm going to choose zoom, and I'm going to choose option 6, a standard window. And that seems to work out perfect. Because my equation was equal to 0, the points that I'm looking for are the two places where this crosses the x-axis, because that is where the y value is 0. And my calculator has features to find them for me. So I'll go second and trace. I am looking for option 2, a 0. So I choose 2. And it will ask me for a left and right bound. So right here my cursor is to the left of this 0, so I hit enter. And then I need to move my cursor so that I am to the right of that 0 and hit enter. And so now my calculator will look in this little range between these two arrows for the 0, and I see my 0 is in there, so I'll hit enter. And it finds that first 0 at 0.23. So that's one of my answers. I have to repeat the process, and so I'll go second, trace, and option 2, find a 0. Now I have to have a left boundary on my second 0, so I need to move over closer to that. Here I am a bit to the left, so enter. And then I have to go a bit to the right, enter. And I can see that in between my two arrows, in between these dashed lines, is my 0, so that's going to work out well. I can move my cursor a little closer for my guess. And I get my second 0 of 1.43. So going back to our slide, when I graphed, it looked like this. And these points here and here are the zeros. And so I used second and trace option 2, which is the 0. And so this one occurs at 0.23, and this one occurs at 1.43. And when I look at those decimals, I'm like, yeah, I don't think I would have ever factored that, so good choice to move on. My next option for solving is taking a square root. And this one is not going to be an option. And that is because I have a bx term. This option has very limited application, and it only works when we have an x squared term and a constant term. But in this case, we have that middle term, so this one is not an option. So then lastly, the other option I have for solving this problem is the quadratic formula. So my quadratic formula is the opposite of b plus or minus square root b squared minus 4ac all over 2a. And it'll depend on your instructor if you have to memorize that or if you will be given that formula. So I want to go back to my equation. My equation is in standard form, ax squared plus bx plus c. So from that, I match up that a is equal to 3, b is equal to -5, and c is equal to 1. Then I put all that in my formula. So the opposite of b is 5 plus or minus square root. B squared is 25 minus 4 times 3 times 1 all over 2 times 3. From there, I want to go to my calculator. And I'll type in just this part called the radicand, which is underneath here. And so I get 5 plus or minus square root of 13 all over 6 when I do that bit of math. Now, this problem will give me the two answers. And so again, it'll depend on your homework question whether you're able to give your answer like this or whether you have to separate it. So my one answer is, 5 plus root 13 all over 6. And my other answer is 5 minus the square root of 13 all over 6. And so those are my two separate answers. And then I can go to my calculator and get decimal approximations. So I would type on my calculator 5 plus the square root of 13, take that answer, divide by 6, and that would be approximately 1.43. And do this math on my calculator, and that would be approximately 0.23. So here is the decimal approximation. We match what is on our graph. One step before that, we had the exact answers separated out, and one step before that, we had the two exact answers written together. So it will completely depend on what you are asked as to where you stop in this process. For this particular problem, we were able to solve by graphing, and we were able to solve with the quadratic formula. We were not able to complete the other two methods. And each problem will vary, so if your homework or your instructor tells you to use a certain method, obviously use that. Of all of the methods, the quadratic formula is the most universal, meaning it works for everything, so you can always go there. Graphing will work when your answers are real numbers, but it does not work when you have complex or imaginary numbers for answers. Factoring and taking a square root have a bit more limited application.